Today on RaceTech, we're going to cover brake pads and rotors. First, starting with rotors. The primary function of your rotor is going to be to store the thermal energy from slowing the car down and to dissipate that thermal energy and to get rid of it in the form of heat. There are two types of rotors that are commonly used in racing, particularly the ChampCar series. Most cars are going to have fixed rotors, like this STI rotor, where the hub section in the middle and the actual rotor surface are all one piece. Some cars run two-piece rotors where the hat is either a separate material or it could be the same material but a separate piece from the actual main surface of the rotor. The advantage of two-piece rotors are that you can replace just the outer friction area and reuse the same hat. You also typically see the hat and the rotor bolted together with either bolts, or sometimes they'll use pins or bobbins, and that allows the rotor to float or move independent of the actual hub, and so that can solve some issues with run out, and it also allows the friction area of the rotor to expand when it gets hot, which on a fixed rotor can potentially cause cracking where the two meet. Rotor mass. The mass of your rotor is important because the rotor has to temporarily store the thermal energy in the actual rotor itself so that it can be dissipated at some point in time on your straightaway to average out the temperature and keep the peak temperatures lower. If your peak rotor temp gets too high, you can develop cracks along the cheek of the rotor. Sometimes these cracks can actually extend into the hat or into the section where the cheek and the hat meet. The risk here is that those cracks will both increase your pad wear, or potentially the rotor could come apart and actually fracture and split at those points, and then it would escape the car and go into the wheel. Rotor veins. The rotor vein design and count is an important consideration when you're picking out a brake package for your car. This rotor has a very big vein area and a large vein count, which will help dissipate more of the brake thermal energy to the air and will reduce your peak and average brake temps. Some rotors have no veins, like this rear rotor, and other rotors will have very little vein thickness and a low vein count. The vein count, the surface area, the number of veins, all those will help you reduce your average and potentially your peak brake temperatures, and it'll transfer more energy away from your rotor and pads and help reduce excessive pad wear. How do you pick a rotor if you want to change the rotor in your car because it lacks enough rotor mass or lacks enough cooling, either via the veins being too small or the vein area being too small? Well, there's a couple different geometries you're going to have to maintain to make that rotor fit your car. And the first one is going to be the outside diameter of the rotor. And looking at this STI rotor versus one of my takeoff neon rotors, you can see the outside diameter is enormously different. The outside diameter, the primary consideration there is you have to fit under the wheel. And your wheel size will probably dictate the largest rotor size that could possibly fit. On some cars, there may be another suspension component you have to clear, some feature the knuckle. So there are practical limits to how big you can go, and you need to size your rotor for that. Another element that you have to keep in mind is the width. And you can see this STI rotor here is 1.25 inch thickness, and the stock neon one is roughly about 7/8 of an inch. That's going to be important if you intend to keep stock calipers, because the caliper will have to actually fit over this, and the pad thickness between inside and outside pad will have to clear this rotor. And obviously you're not going to be able to put this 1.25 inch rotor in the caliper that housed the 7/8 rotor before. If you're running aftermarket calipers like Wilwoods, they typically come in 2 or 3 different sizes for what they call bridge thickness, and that thickness is how big the rotor can be and actually fit inside the caliper. Wilwoods typically come in 1.25 inch and 1 inch and 7/8, roughly speaking, and you want to size the caliper to match the rotor you intend to run. Another thing you got to keep in mind is the hat diameter, which, looking at this STI rotor, will be the inside diameter here where the brake rotor has to fit over top of the hub. You have to make sure that your hub will actually clear the rotor. The rotor is actually bigger in diameter on the inside than the hub is on the outside, but it also helps to have it be a little bit larger, and you'll find most cars do this to allow a little bit more airflow in to help cool the back side of the hub, which will cool the bearings and also it makes it easier to fit on when you're installing it. Offset is another important consideration, and the offset is the distance between the center line of the rotor and the face of the rotor where the wheel goes on. This is important particularly if you intend to run a stock caliper, because the caliper will only allow the OEM offset plus or minus some small amount that the slides can actually move. And if you intend to run an aftermarket caliper, actually fitting the caliper under the wheels, you have to keep in mind the hub offset that will work with your wheel. You can change the hub offset somewhat with underhat spacers, or putting what looks like a wheel spacer under the back side of the rotor between it and the hub, but that's going to eat into the length of your wheel studs, so you typically don't see that done much on cars in our series. The other thing you need to keep in mind is the bolt pattern and the hub bore for the rotor has to match or be very close to the original car's hub bore, and obviously the bolt pattern has to match up. So in this case, it's important because the rotor has oversized holes for the wheel studs. So the wheel studs will not actually locate the rotor to the accuracy required to keep it from vibrating or pulsating on the car when you hit the brakes. So you'll either need to make a ring, just like a wheel spacer ring you have on wheels when you run the wrong hub bore for your given hub, or you have to find the rotor that has the right bore for your particular hub. When you're selecting rotors, you need to keep in mind the quality of the materials and the fit and finish of the rotor that you're buying and running. One of the issues you could potentially run into with poor quality rotors is that the surface finish is actually rough enough that you have increased pad wear. Most rotors you're going to buy are going to be made of gray iron, but the quality can make a difference, and poor quality materials will generally have poor finishes on them and will lead to increased brake pad wear. Poor quality materials can also lead to crack propagation, or the cracks growing at a faster rate than you would in a good rotor. Some other things I've seen is the rotor flatness, surface finish not being correct, or the parallelism, or how straight the two faces of the rotor are to themselves, being poor, can lead to pulsations at the end of a straightaway when you're going really fast. You can typically avoid these by buying, at least a reasonable quality rotor from a recognizable name. I use Raybestos. Frozen Rotors is another vendor you can get good advice from, but spend a little bit more money to avoid having issues down the road, and potentially doubling your rotor useful life will actually lead to a reduction in costs. Rotor slots and holes. You've probably seen tons of brake gimmick parts on the internet with varying numbers and locations of holes and slots. The concept or the theory behind that is that the slots will help with outgassing when the pads get hot enough that they actually have some gas element come out of them. You have a path for it to escape. I've never had a need to run them. I typically stay away from them both from a cost standpoint and a quality standpoint. If you go with rotors that have holes drilled in them, you are inducing points where you can have cracks propagate between holes. That's why you typically don't want to drill holes in it yourself. They should be cast in. In general, you're going to find a lot of the products that are out there online that are not from reputable vendors, that are slotted or have holes in them, just aren't worth the effort. And I would just go with a quality, good material, OEM takeoff rotor combination.
I thought holes were originally to lighten the brake rotor.
It's supposed, yeah. So like
outgassing was something that they said on the street.
It's been sold a couple different ways. For the same rotor mass, if you put holes in it, it's going to cool better than a equal massed rotor, because it's like the surface area versus the weight thing.
Oh, right.
You're getting better, but it's a lot of holes, a lot of work. And like typically you see them done and they're just not done well. Like when you drill the hole in it, you are introducing some stress concentration factor, like some potential place for it to break, and especially if it's production run drilled in a hurry and not cleaned up. But in general, you're just paying a premium to get something that's not going to be as good as a factory part. Rotor failures. Some of the possible rotor failures you'll see on track would be cracking, either through the cheek, which is the outside surface of the rotor, or through the hat, and these can be surface cracks, or cracks that actually go all the way through the entire cheek. Another issue you run into is warping, where when the rotor gets excessively hot, it's no longer flat and parallel. You can also get hot spotting, which is typically an issue where the rotor was machined incorrectly, and you get different pad thickness buildup in areas of the rotor, and that creates differences in friction as the rotor rotates. That will lead to pulsation that you feel as the pedal shaking, which also is sometimes called judder, and the drivers will often complain that it's hard to not lock the brakes up because they can actually feel the stick slip as you go across sections of the rotor that have different friction. So you just got those new brake rotors in the mail. You'll find they're probably wrapped in a bag, and in that bag the rotor has been coated with a rust inhibitor, some kind of light oil. And that's important because the rotors will rust really quickly, and if you tend to store them in your trailer for a while and you don't need them right now, leave them in that bag or even potentially spray them down with some more WD-40 to keep them from rusting. But before you put the rotors into service on your car, you need to make sure you use brake clean to clean off the rotors to get rid of all those oils, because those oils will end up on your brake pads and they'll reduce your braking performance for some period of time, hopefully just a little bit, but some of those oils can actually stay in the pad long enough that for several laps you end up with reduced brake performance. And it can be surprising for the driver who's expecting the capability of normal brake performance. Brake clean is typically offered in an entire case at a reduced price, and you'll find it's useful for all kinds of general purpose cleaning. So when you're out there, just buy a whole case. Brake pads. Your brake pads have a couple of basic design considerations and functions they have to provide. The most obvious one is that they have to provide the actual friction that the car needs to stop. They provide the friction that creates the heat that converts your kinetic energy into thermal energy. Another function of your brake pad is the brake pad backing material has to distribute the actual caliper piston force over the entire brake pad surface area. This is the primary function of the steel backer on your brake pads. Your brake pads also have to be a thermal barrier to help prevent some of the heat in the brake pad from transferring through the backing plate into the brake caliper and thus the brake fluid. Brake pads also have to provide a wear surface because ideally you will consume the brake pad material faster than the rotor so that you can use the rotor more than once. It's important to have even brake pad pressure distribution to get proper brake performance. One of the ways you can handle this in racing applications is with multiple pistons in your brake caliper. You don't see much of that in our series, but for Pro Race series you'll typically see the piston sizes vary from the leading edge to the trailing edge of the caliper, depending on which direction the rotor is rotating. And typically you'll see bigger pistons on one side, smaller on the other. For our calipers, and most people tend to race sliding calipers in ChampCar series because that's what their car came with from the factory, you need to make sure that your caliper slides are well lubed and cleaned and checked every time you replace the brake pads. This will make sure that you get even brake pad pressure distribution on both the leading and trailing edge of one pad and also between the inside and outside pad for a given wheel. You often see OEM brake pads will have chamfers in them or slots cut in them. These are generally for noise reduction or to reduce vibration. And if you don't have these on your race pad, I wouldn't worry about it a whole lot. Same goes for the grease or the backer plates you often see that are friction reducers on the back. They can help somewhat with the pressure distribution on the pad, but they're generally there to get rid of noise and squealing when you're applying the brakes lightly like you typically see on a street car. Using quality backer plates for your pads is important for proper brake operation, and if you have brake pads made for you by Carbotech or Raybestos or one of the other aftermarket brake pad manufacturers, you need to make sure they're using a proper, good quality backing plate. They typically do, but the importance here is that you need the backing plate to both fit in the caliper correctly, meaning it doesn't hang up or drag anywhere, and also be stiff enough and strong enough that you don't get uneven pad pressure distribution because the brake pad is actually flexing. You'll need to keep the brake pad flat and keep the pressure even to get even pad wear and to get optimal stopping performance. Picking a brake pad for the temperature range you intend to run in is also very important because brake pad wear is typically non-linear, meaning once you get over the design temperature range for your brake system, your pad wear will go through the roof. You typically find this in our series if people run pads that are not recommended for endurance racing. They'll run a pad that's good for autocross or maybe high performance street driving, and they'll take those and drive them on track with a stock or nearly stock size rotor and drive their brake temps up so high that their brake pad wear goes from a race for a set of pads to a handful of hours. So work with your brake pad manufacturer or supplier and make sure you're sizing the compound to match the expected temps you intend to see with your particular setup. You need to make sure you're sizing your brake compound for the temp range you intend to run, because brake pad wear is typically non-linear, meaning if you get your brake pads outside of their operational temperature recommendation, the wear will go through the roof and will become a fraction of what you typically would have if you just remain a couple hundred degrees cooler. When you're working with your brake pad manufacturer, let them know what you intend to do, that you intend to endurance race, because if you pick a compound that's designed for autocross or high performance street driving, typically those pads are designed to work at a colder temp range and their friction may be better at cold temps, but you will quickly get them past their upper temp limit and your wear will go from a typical 1 pad replacement per race weekend to a pad replacement every couple hours. Another consideration when you're picking out brake pads is total pad volume. The pad volume, or the amount of friction material that's in your brake pad, will help determine your wear limits, or how long you can go on a set of pads before you replace them. You can increase your pad volume by running a pad that's longer if it fits inside the caliper. You can also increase your pad volume by making the pad thicker if you have room to fit the extra thickness in your caliper given the rotor choice you've made. When picking out calipers, if you have the option between 2 different calipers that will both fit your car, you may want to look at pad volume, because the pad volume could potentially allow you to replace your brakes less often. And although it costs money up front to buy a different caliper and it may be more expensive to buy a pad that has more pad volume, the fact that it lasts longer may actually make more financial sense. When you're shopping for brake pads, one of the parameters that's often advertised the most is brake mu, which is the coefficient of friction, or the amount of output force for a given input force of the brakes. Higher mu pads will provide more braking power for the same driver pedal effort, meaning the car will stop faster for the same amount of force the driver is pushing on the pedal. Although this is advertised as a really important parameter, there are other parameters that are even more important, because you can typically get more brake output force with resizing of the brake caliper piston bore size, or even if you have power brakes, changing the brake booster size. Some of the other parameters I think are equally or even more important than brake mu would be brake release, or how much does the brake force drop when you reduce the pedal pressure, and how quickly does it drop. This is important to prevent or to stop the brakes from being locked up. When the driver notices the brakes are locked and he releases the brake pedal, you need it to very quickly and instantly reduce the brake force at the wheel. Another important parameter is going to be initial bite. And the initial bite of the brake pads is how much brake force do you get at low pedal output when you first touch the brakes. This can be confidence inspiring for the drivers that you have in your team. They will typically like touching the brake pad and feeling the car stop a bunch at low pedal force. The issue here is if the initial bite is too high, you'll find a lot of drivers will inadvertently lock the brakes at low pedal effort, and combined with poor release, high initial bite can become a real problem and create flat spots for you. Also, you'll find brake pad wear can be even more important than peak mu or average mu, because allowing the brakes to last an entire race weekend or multiple race weekends can really impact your bottom dollar and potentially be more important than stopping a little bit quicker than the next guy. You also will find that between 2 brake pads that have the same advertised temp range, some brake pads have better life or can better handle higher temperatures above the recommended rating than others. This can give you more safety margin and can also allow you to have better brake pad wear, something I think is equally or potentially more important than outbraking the guy next to you by a foot or two. Just like the brake rotors, you just got your new brake pads in the mail and they come in a package that's covered in plastic. That's for a good reason. If you get oils or greases on the friction surface of your brake pads, it's going to severely impact your braking performance until you're able to burn those out. And that could be a little while or a long period of time. So make sure you put gloves on if your hands are all grubby and covered in wheel bearing grease. And don't stick them in a bucket or some other container where they roll around with greasy engine parts. Leave them in the box and the packaging they came in. If you happen to get something on them, make sure you thoroughly clean them, spray them down with brake clean, and make sure you wipe them down really good. Well, that wraps up our brake system basics. Make sure you click to subscribe to this channel, leave any questions or comments you have on this topic or any other topic, and we'll see you next time here on RaceTech.